Welcome to part 3 of the anatomy of the vertebra and understanding human anatomy. This lesson will concentrate on looking at how two vertebrae articulate or join together with one another. So we'll start by drawing in a second vertebra just underneath the one we have already drawn in. So there's the body, the pedicle, superior articular process, inferior articular process, and the inferior surface of the pedicle. The lamina, transverse spinous process, and transverse process. And I'll erase the junction between lamina and pedicle within the transverse process. Now, you notice that there is a gap between the bodies of the two vertebrae. This gap is occupied by the intervertebral disc, and I'm going to draw the disc in blue. Like so. So this is the intervertebral disc. Remember again, inter is a prefix that means between. So this is the disc between vertebrae. Intervertebral. The intervertebral disc. It is composed of a fibrous material called fibrocartilage with a gelatinous core. Also, notice that there is a hole, and in anatomy we call holes foramen or foramina, is the plural, we have a hole between the two vertebrae. This is the inter means between, vertebral foramen. It is there to allow spinal nerves, which form on the spinal cord or from the spinal cord, to exit the vertebral canal so that they can get out to the tissue. Each spinal nerve supplies a segment or an area of the body. Now, the two articular processes meet to form a synovial joint. This joint is called the zygapophyseal joint. It is a true synovial joint. Synovial joints are joints that are freely movable. It's the kind of joints we have in our shoulder, in our hips, in our elbows, in our knees, in our wrists, in our hands. It allows free movement. In all synovial joints, there is a space between the bones that is filled with fluid that lubricates the joint to allow easier motion between the two bones. Also, the surfaces of the bones that are in contact with one another are covered with cartilage to provide a smooth, glassy next surface. Slide, or this next drawing, we're going to look at the structure of the intervertebral disc. So what we're going to do is draw a cross section through the disc. Like before, when we looked at a cross section through the body, it went through the vertebra. Now we're going to be a little bit more precise and put it right through the intervertebral discs. So we'll see the disc as it would be viewed from above. And what we see is that it is a circular structure and it's made up of an outer ring of fibrous tissue. Now, this is a very specialized type of tissue we find in the intervertebral disc. This type of tissue is called fibrocartilage. Fibrocartilage is a hybrid or a combination of the kind of connective tissue that makes up a tendon or a ligament and of cartilage, a more structural tissue. As such, it is very strong. This fibrocartilaginous ring is called the Annulus Fibrosus. the Annulus Fibrosus. And the Annulus Fibrosus forms the outer structure, the true support of the intervertebral disc. It attaches to the body of the vertebra above and the body of the vertebra below and holds them together. Now, when we have a joint made up of fibrocartilage, we call that a symphysis. So the annulus fibrosus forms a symphysis type joint between the bodies of adjacent vertebra. Now, the inside of the intervertebral disc is composed of gelatinous material. Just filling the inside. This gelatinous material is called the Nucleus Pulposus. The Nucleus Pulposus. And the Nucleus Pulposus serves as a shock absorber for the intervertebral disc. It's soft. It can be slightly compressed and is relatively fluid. It's consistency of, say, soft jello. And it absorbs the shock that our spinal column is subjected to each time we take a step. Each time your foot strikes the ground, the weight of all the vertebra above and all the structures in that area of the vertebra press down. And it would be a very jarring sensation if we didn't have these intervertebral discs with the nucleus pulposus to cushion those shocks each and every time we take a step. So the nucleus pulposus provides the shock absorber of the intervertebral disc, while the annulus fibrosus holds the bodies of the vertebra together to prevent them from moving apart and sliding off one another. Now, clinically, I'm sure you've all heard of a slip disc. And that term is really an incorrect term, a misnomer. As you see, the disc isn't a solid mass that can slide. It's a tough outer ring with a soft gelatinous core. A slip disc is really a herniated disc. And a herniated disc occurs when there is a defect or a hole in the annulus fibrosus. And when that happens, the nucleus pulposus can gradually work its way out through that hole or defect. And the nucleus material, the gelatinous material of the nucleus, will then protrude out where it can put pressure on structures nearby. And the structure that's closest with the vertebra are the spinal nerves. So when someone has a herniated disc, the nucleus pulposus oozes out and puts pressure on the nerves, and that causes pain in the back. And you feel pain radiating down the leg generally, since it's lumbar vertebra that most likely herniate like this. So that is a herniated disc. In the last video of this group, we will look at the various ligaments that hold the vertebral column together, and then summarize what we've talked about in the vertebral column. Thank you for your attention.